All right, let's talk about the invisible force that shapes pretty much everything around us. It's in the buildings we live in, the phones we use, the water we drink. We're talking about engineering, the incredible and often hidden engine of all human progress.
So think about this for a second. What on earth could an ancient, simple tool for moving water have in common with the supercomputer you carry around every day? Well, the answer isn't a thing. It's a way of thinking. It's a process that's been driving us forward for thousands of years.
And this is the secret sauce right here. At its absolute core, this is what engineering is. It's not just about building stuff. It's a mindset. It's about seeing a problem in the world, grabbing the tools of science and math, and then creating a real, tangible solution that actually helps people.
So what does it take to be an engineer? What's in the toolkit? Well, yeah, obviously you need the math and the physics. That's the foundation. But that's just the start. You need real creative thinking to even imagine a new solution. And this one might surprise you, you need amazing communication skills. Because what good is a brilliant idea if you can't convince anyone to build it? The best engineers, they're not just number crunchers, they're storytellers.
Okay, so let's see how this actually played out through history. Because if you look closely, the story of humanity isn't just about battles and borders. It's a story about problems. And for every single problem, an engineering solution was there to push us to the next level.
And you see this pattern again and again. The moment humans started farming, boom, new problems. How do we get water to the fields? How do we build better tools? The answers were some of the first feats of engineering. This cycle just keeps repeating. From the mind-blowing advances during the Islamic Golden Age, to the Renaissance where art and engineering merged, to the steam engine which literally changed the world, and right up to our own digital age.
Let's just pause on that for a moment. In the 12th century, a scholar named Ismail al-Jazari was designing these incredible automated machines. We're talking complex clocks, fountains, even musical automata. Today, we call him the father of robotics. Think about that. That's almost 1,000 years ago. It just shows you how deep these roots really go.
Now, let's jump forward about 600 years. In 1776, James Watt's improved steam engine wasn't just another cool invention. No way, this was the spark that lit the fuse. For the very first time, we had a way to create powerful, reliable motion from energy anywhere. This single piece of engineering kicked off the entire Industrial Revolution, forever changing how we work, live, and build societies.
And that chain reaction just kept going. Fast forward to 1913. Henry Ford didn't invent the automobile, we know that. But what he did was engineer a whole new way of building it, the moving assembly line. That was a breakthrough in process engineering. It was all about making things faster, cheaper, more efficient, and it completely rewrote the rulebook for modern manufacturing.
Okay, so that brings us pretty much to today. And as our world has gotten way more complex, so have our problems. So engineering had to adapt. It had to specialize. It's not just one field anymore. It's this huge, sprawling ecosystem of different disciplines.
We can kind of sort all these specialties into a few big buckets. You've got the engineers who build the world we live in. The roads, the bridges, the clean water systems. Then you have the ones creating our tech, the chips, the circuits, the gadgets. Others are focused on making our industries run better. And of course, some are literally shooting for the moon with aerospace. Every single one is a vital part of our modern world.
And people get these two mixed up all the time, so let's clear this up. Computer versus software engineering. Here's the best way to think about it. The computer engineer builds the theater. They design the physical stage, the lights, the sound system, the building itself. The software engineer writes the play, the script, the story, the performance that happens on that stage. One builds the hardware, the other builds the code that makes it do something amazing. You can't have one without the other.
So how do all these different engineers actually work together? How does an idea become a thing? Well, it's a pretty logical journey. It starts with a spark in R&D. Then design engineers give that idea a shape, a blueprint. Planners figure out, okay, what do we need to actually build this? Then production makes it happen. And all along the way, at every single step, quality control engineers are testing and testing and testing to make sure it's safe and it works. It's like an incredible relay race from imagination to reality.
So, where do we go from here? The story of engineering has always been about rising to the next challenge. And today, the challenges we face are bigger and more urgent than ever.
And the problems of our time are huge. We're talking about climate change, running out of resources, making healthcare work for everyone, and securing our digital lives. But here's the hopeful part. For every one of these massive challenges, there is a corresponding engineering mission. The goal is to invent new energy systems, to develop affordable medical technology, to build a safer internet. Engineers are right on the front lines of solving these things.
And this really is the key takeaway. This is the whole point. Progress isn't born from easy times. It's our biggest challenges, our greatest problems that force us to be brilliant. They're the fuel for innovation. And history shows us time and time again that engineering is the engine that turns that fuel into progress.
So you see, from a simple water screw all the way to the future of our planet, the story of engineering is really our story. It's about human creativity and our stubborn refusal to look at a problem and just give up. And that story, it is far from finished. Which leaves us with a pretty big question. What problem will you solve?